Welcome back to Geometry Chapter 8, Section 2 in this book. And it is problem solving in geometry with proportions. We've been talking about similarity, shapes that are the same shape but different sizes. And you can make a ratio to describe it, like one is twice as big as the other, it's 2 to 1. Where transformations, what we talked about in Chapter 7, is where they're the same size and shape. These are different, they're just similar. They're not the same size, they're the same shape. Okay? So how you can write this is by proportions, and you read it like this. If A is to B as C is to D. And it means that it's the same ratio, it's the same proportions, it's the same fraction that describes one shape as the other one. Now this is a little rule that if you have A is to B as C is to D, then you can flip and switch the middle two. If you remember last time we said the middle two are called the geometric mean, and you're allowed to switch them. So that's our first little thing we're learning that we're allowed to do, is you can put the B where the C was and the C where the B is, and it's allowed. Okay, here's the second thing that's allowed. You're allowed to take the denominator and add it back to the numerator of both of them. See, this one's denominator is B, so I can put a B up there. This denominator is D, I can put a D up there. You're like, why would I want to? Trust me, later on, you might want to. Okay, so these are things that are allowed. Okay, so let's see, is this allowed? We have y is to 6 as x is to 10. Did we switch those? Whoop, yes, we did. So it's allowed what we did. All we did was use this rule and switch them. You're allowed to switch these to the mean. You're not allowed to switch the extreme. You switch the mean, not the extreme. You switch the mean, not the extreme. Okay, how about this? If you got x over 3 is to y over 4, are you allowed to write the denominator back up top like how we did here? Yes, you can. Are you allowed to write the denominator of this one on that one? No, you're not. So the book did this one for the example for A, that one for B, but it's very confusing how they have written it while they're saying it's false, because they write, this is a proof for it. So just look at mine instead and maybe don't look at theirs. Alright, if you have a triangle and you draw a parallel line going across from the base, it cuts the triangle into a similar little triangle. This triangle is similar to that one. And as a result, we can write a ratio. A is to B as B is to D. This section is to this one as this section is to that one, as AC is to CE. Now they want us to figure out what's the missing term. We know this one's 16, that one's 10, and we know this whole thing is 30. We need to know what that one is. We always have to make sure we're comparing apples to apples and oranges to oranges, just like when we talked about the feet and the inches last time. So if that's 30 and that's 10, what is this? 20, right? 30 minus 10 is 20. Now we can set up our ratio like this. 16 is to x as 20 is to 10. We're going to cross multiply and solve for x. 16 times 10 on this side is 160. X times 20 is 20x on this side. Y is x on line, it's multiplied by 20. What's the opposite? Divided by 20. What you do to one side, you do to the other. 160 divided by 20 is 8. Okay? Here's another one. What about if there's two x's there? What do? The same thing. You just cross multiply and solve for x. What's x times x? X squared. 8 times 18 is 144. Why is x on line? It's being squared. What's the opposite? Square rooted. What you do to one side, you do to the other. What's the square root of 144? It's 12. And these are distances. These are measurements of shapes. So we don't have to do plus or minus 12. It's just 12. All right, here's another one like that. 210 is to x as x is to 420. We're going to cross multiply. X times x is x squared. 210 times 420 is that big number. So y is x on line, it's being squared. What's the opposite of square rooted? How do you square root that number and it not be a decimal using your calculator? You have to make a factor tree. So you think of any two numbers you can multiply together to get that, and I thought of 100 and 882. You can do a different one. You can start with 2. You'll get the same answer. And then what you're looking for is twins. So 2 factors of 100 is 10 and 10. That's a pair of twins. So I got 1 pair of twins, I need more. 882 is factors is 2 times 441. And 441 is 3 times 147. And 147 is 3 times 49. And 49 is 7 times 7. So I have another set of twins and another set of twins, and I got one that's not a twin. Well, if you have a twin, one gets dissolved in acid and the other one gets out of jail. So this one gets dissolved in acid, that one gets out of jail. This one gets dissolved in acid, that one gets out of jail. So then these 3 are out of jail, you multiply them back together and it goes outside the radical. What's still in jail? 2. And so this is the answer to what x equals. And it's more proper to have the radical than to turn it into a decimal, because the radical is equal, the decimal is only approximately equal. Alright? Not bad. Have fun. Do your homework. Math is great.